Hi students, welcome to today's class. So today also we are going to discuss some very important concepts of the hyperbola. Okay, so in our today's class, so we are going to discuss what are parametric point and parametric equations. Parametric equations. Parametric equations of the hyperbola. So we know that equation of the hyperbola in general form is x square by a square minus y square by b square is equal to 1. So it's the equation of the hyperbola. So in this x is equal to, let us take as a secant theta, y is equal to b tan theta you take. So this x is equal to a secant theta, y is equal to b tan theta satisfies this equation, that is namely x square. That means in place of x substitute a secant theta. So this is a square secant square theta, a square will get cancelled, you will get secant square theta. In place of y substitute b tan theta. So b square tan square theta, b square gets cancelled, so you will get tan square theta. So secant square theta minus tan square theta is equal to 1. But here the condition should be, the condition, what is a theta? What is here theta? Theta is a called eccentric angle of the hyperbola. Theta is eccentric angle of hyperbola. In the ellipse, we have explained taking auxiliary circle and writing the perpendicular, all those things there, what are maybe the eccentric angle. For the hyperbola also the same concept applies here for this theory. Now what is the what you call here, what is the angle between, what is the range of the angle theta? So the range of the angle is 0 less than or equal to theta less than 2 pi radians. That is theta belongs to closed bracket 0 to 2 pi. Here you have to take an angle, which satisfies both the equations, understand? So for example, if you take theta is equal to 0, it satisfies both the equation. Why? Because here secant 0, cos 0 is 1, secant 0 is also 1, tan 0 is 0, you can take, no problem. But if you take theta is equal to pi by 2, for example, if you take theta is equal to pi by 2 radians, tan pi by 2 is not defined. Tan pi by 2 is not defined, whereas secant pi by 2 is. So cos 90 is 0, cos 90 is 1, secant 90 is also 1, sin 0, 0, cos 0, 1, tan theta is, secant theta is defined, whereas tan theta is not defined. Okay, now such type of angles you should not take. So you have to select an angle for which both the equations are valid. Understand? So that is a very important point that you should keep in mind. Okay, now right. Now what are the, this is now what is a parametric point? Parametric point means, so this is a parametric point, a secant theta comma b tan theta is the parametric point, a secant theta comma b tan theta for any angle of theta, of course, which satisfies both the equations of these parametric equations. So this will belongs to this hyperbola x square by a square minus y square by b square is equal to 1. So for our convenience, this point is denoted with the letter theta. Okay, so if it is alpha is there, now your angle is CA secant alpha b tan alpha. If it is a beta is there, CA secant beta and b tan beta. So a secant alpha comma b tan alpha is denoted with the letter alpha. A secant beta comma b tan beta is denoted with the letter beta. Okay, now so these are about the parametric point and parametric equations. Once again I am telling, theta is the parametric angle of the eccentric angle of the hyperbola from auxiliary circle point we will discuss. Okay now. So I hope that you understand this concept. Let us go for next concept. Welcome back to this concept. So here we are going to see the tangent and normal to the hyperbola. So we know the definitions of tangent and normal. So a tangent is a line which touches the hyperbola at a point. It is called a tangent, and that point is called point of contact. So normal is, it is a line passing through this point of contact and perpendicular to the tangent is called the normal to the line. So tangent and normal are the lines. Now let us see that. So this is a parametric equations and this is general coordinate algebraic equations. So if a point p x1 comma y1 is on the hyperbola, p x1 comma y1 is on the hyperbola. So the point p is on the hyperbola x1 comma y1, then the equation of the tangent passing through this hyperbola. So this point p x1 comma y1 and touching the hyperbola at px1 comma y1 is obviously s1 is equal to 0. For s1 is for all, for circle, parabola, ellipse, hyperbola, for all s1 is equal to 0. Already we have given the in the notations what is x1 is. X1 means what? X1 by a square minus y1 by b square minus 1 is equal to 0. This is s1 is equal to 0. Okay now. Now coming to at theta, the equation of the tangent is x by a secant theta minus y by b tan theta is equal to 1. So it is also very easy to remember. So what is the parametric point on the hyperbola? We have taken x is equal to a secant theta. So this is a secant theta, y is equal to b tan theta. So this is x1 y1. So in place of x1 substitute a secant theta, in place of y1 substitute b tan theta. So this is a x into x1 plus a secant theta by a square minus y into y1 plus b tan theta by b square minus 1 is equal to 0. So this is a x secant theta by a comma y by b tan theta is equal to 1. That's all. X by a secant theta minus y by b tan theta is equal to 1 you got. That means if you remember this first formula, so the parametric point equation of the tangent at the point theta, it is not at all difficult. Okay na? Very nice. Now coming to the normal, so in the coordinate system x1 comma y1, the equation of the normal at the point x1 comma y1 is a square x by x1 plus b square y by y1 is equal to a square plus b square. For the ellipse, just you compare both the formulas. There here plus minus b square will be there, here plus b square. So here also ax by secant theta plus b by b tan theta is equal to a square plus b square. So this is no need to by heart this second formula in the parameter. If you remember the first formula, that is a square x by x1. In place of x1 substitute a secant theta. In place of y1 substitute b tan theta. You simplify that, you will get the answer. Ax by secant theta plus by by tan theta is equal to a square plus b square. So my sincere thing is, so if you remember, I think this is the only formula that you have to remember. That's all. A square x by x1 plus b square by y1 is equal to a square plus b square. So if you remember the formula equation of the normal, so remaining all formulas is easy. Why? Because it is already, it is for every conic section, equation of the tangent is s1 is equal to 0. Automatically this will come and this will come. And if you remember this, in place of x1 put a secant theta, in place of y1 put b tan theta. You do a small rough work, you can get this. So for all these formulas, so this is the main head formula. Okay now? Right. Even then, so even though if you didn't remember that, so using this tangent equation, you can get the normal equation. Okay, that also there is. Okay, I hope that you understand this concept. So let us go for next concept. Dear students, welcome back to the very important concept, that is asymptotes of a hyperbola. So before learning this asymptotes of a hyperbola, so what is asymptotes of a conic? Conic may be anything. So let us learn the asymptotes of a conic. So asymptotes are the lines. So let us take the hyperbola. So let us take this hyperbola C. So asymptotes are the lines which touches the, that means they have a common point with the hyperbola, but it touches the hyperbola at infinity. That means they passes through the center, but they touch the hyperbola at infinity. They touches the hyperbola at infinity. Somewhere at infinity they touches. So first of all, asymptotes are the tangents. Actually they are tangents and passes through the center of the hyperbola and they touches the hyperbola at infinity. Somewhere at infinity they touches. Okay, they are called the asymptotes of the hyperbola. Not only hyperbola, for any conic, they are the tangents which have the common point at infinity. Somewhere at infinity, but they will have a common point. Two common points they will have and they are at infinity. Such lines are called asymptotes of the hyperbola. Okay, now then how to find out the equations of the asymptotes of the hyperbola is means let us see the derivation. So first thing, what is the equation of the hyperbola? X square by a square plus y square by b square is equal to 1. Let y is equal to mx plus c be a straight line. Y is equal to mx plus c be a straight line, any straight line. Okay, let us solve these two equations. That is equal to x square by a square minus, in place of m, substitute mx plus c. Mx plus c whole square by b square is equal to 1. So this will become b square x square minus a square into, you expand this, m square x square plus 2mcx plus c square is equal to a square b square. Okay now? Right. Now let us write it in the, what you call this, quadratic equation in x form. Why? Because why I am taking, why we are writing this in terms of x means, so this hyperbola, so this tangent touches the hyperbola at infinity. Therefore here x tends to infinity, x value tends to infinity. Of course y also, according to y also tends to infinity. So let us write it in the quadratic equation form. B square, this is a square m square into x square minus 2a square mcx minus, take that side, a square c square minus a square b square is equal to 0. So one more step I will write down, b square into a square m square into x square minus 2a square mc into x minus, you can take a square common outside. So if you take a square common outside, c square minus b square is equal to 0. Understand this? So this is a quadratic equation in x, that means abscissa. Here it has two roots x1 and x2. They are called the abscissa of the point of this, not intersection, touches, where it touches. If y is equal to mx plus c line happens to be the asymptote of the hyperbola, so asymptote of the hyperbola here in this equation, so x square and the x terms, that means it has two roots, no, so that is x1 and x2, they happens to be infinite, that means they tends to 0. x1 and x2, they tends to infinity there. So therefore here x square and x terms, coefficients of x square and x terms should be equal to 0. That means here b square minus a square m square should be equal to 0, and here 2a square mc is equal to 0. Those are the conditions. So b square minus a square m square is equal to 0, and you have, okay, 2a square mc is equal to 0. So these are the conditions that the line y is equal to mx plus c line to be a tangent to the, to be a asymptote to the hyperbola x square by a square minus y square by b square is equal to 1. So let us get an equation of the asymptotes through this equation. Okay. So here we have the condition regarding m, that is equal to b square minus a square m square is equal to 0. From this m square is equal to b square by a square. This implies m is equal to plus or minus b by a. That is we got from the first condition. Now coming to the second condition, so this is equal to 2a square mc is equal to 0. Here a cannot be equal to 0. Why? Because here a is what? A is the semi transverse axis. Okay now, so that cannot be equal to 0. M also cannot be equal to 0. Why? Because if m is equal to 0, then this asymptote the asymptote should be parallel to x-axis, and should be parallel to x-axis, maybe x-axis also. So x-axis cannot be the asymptote of the hyperbola. If is any line, if you take any line parallel to x-axis, it intersects the hyperbola. That means it intersects the hyperbola. So this is m is equal to 0. Then that line intersects the hyperbola. That's why m also cannot be equal to 0. There is a one and only one possibility, that is c is equal to 0. Okay now. So now what is the line you have taken? Y is equal to mx plus c. mx plus c. So in place of m, substitute here in place of m what you have got? Plus or minus b by a x, plus in place of c we got 0, that is equal to y is equal to plus or minus b by a x. So these are the equations of asymptotes. These are the equations of the asymptotes. Understand this? Okay now. So if the line y is equal to mx plus c is happens to be asymptote of the hyperbola x square by a square minus y square by b square is equal to 1, then the conditions already, these are the two conditions, that is b square minus a square m square is equal to 0, that is m is equal to plus or minus b by a, and the second condition is c is equal to 0. Now substitute here in place of m plus or minus b by a, in place of c is equal to 0, this is y is equal to plus or minus b by a x. So that means equation of one asymptote is y is equal to b by ax, another equation is y is equal to minus b by x. So therefore one slope is, one of the asymptote slope is b by a, another slope is minus 1 is equal to minus b by a. Okay. Now if theta is the angle between the asymptotes, if theta is the angle between the asymptote, then how to find out the angle between the asymptotes? Let us see that concept. Okay. Welcome back. Let us see the angle between the asymptotes. Two asymptotes, angle between the asymptotes. So let us take this hyperbola. So this is the center. Already we have seen that the asymptotes are the tangents which touches the hyperbola at infinity. So therefore, so this is equal to theta. So already we are given that y is equal to plus or minus b by a, that is y is equal to, one equation is b by ax, y is equal to minus b by x. That means whatever may be that sign, m is equal to tan theta, y is equal to mx. So here m is equal to tan theta is given by b by a, that is equal to theta is equal to tan inverse of b by a. Here what is the theta? Theta is the angle made by the asymptote with x-axis, in the positive direction. That means up to here only this angle theta, up to here only theta. So theta is equal to tan inverse of b by a. So that is the angle made by the asymptote y is equal to mx, that is y is equal to b by a x with x-axis is tan inverse of b by a. But angle between the asymptotes means, so this is a complete angle you have to take. That means this is also theta. So if it is that means those two lines are symmetric about with the x-axis. And y is equal to minus b by a x also. If you say that, if you draw that, this is also here slope is equal to minus b by a. So therefore these two angles must be equal. Therefore angle between asymptotes is equal to 2 theta. Actually, this is theta, this is 2 theta, means 2 times tan inverse of B by A. 2 times tan inverse of B by A. So, that is the angle between the asymptotes. Otherwise, we can write it as a 2 times secant inverse of E. That also you can write down. Tan inverse of B by A. 2 times secant inverse of E, where E is the eccentricity of the hyperbola. Okay now. So, I hope that you understand this concept. Now, I am going to explain in geometrically how to construct asymptotes. Geometrically how to construct asymptotes, how these equations came. Y is equal to plus or minus B by AX, how is this mathematically derivation I explained, but in another way also we can derive the equations of the asymptotes in geometrical construction way. Okay. So, let us see how to construct asymptotes geometrically. Okay now. Welcome back. So, here how to construct the asymptotes of the hyperbola geometrically, how to construct. So, very easy to very easy concept this is. Let us take the hyperbola. Let us take the hyperbola. So, this and this is conjugate axis. Let us take the conjugate axis, and it is A and it is A dash and it is a B and a B dash. Okay. So, let us draw the parallels. Let us draw the parallels parallel to the conjugate axis. What is meant by this means these are the parallels. I am drawing the parallels. So, one of the parallel definitely passes through the A. This side also I have drawn the parallels. This side I have drawn the parallels. One of the parallel passes through the A dash. Okay now. Similarly, draw the parallels, parallel lines parallel to the transverse axis. So, parallel to the transverse axis, this is parallels. Definitely one of the parallel line passes through B. Here also draw the parallel lines, definitely one of the parallel line passes through B dash. Let the parallel line, that is this passes through A and B dash, they intersect at K1. Let these two parallel intersects with K2. Let these two parallel intersect K3. Let these parallels intersects to K4. Understand? Okay. Now, join K1, C, K3. So, that means join this. So, this is K3. So, this is K3. Join K1, C, K3. So, this will be your 1. So, that means K1, C, K3. And then another one is join K2, C, K4. K2, C, K4. K2, C, K4. These two are nothing but asymptotes. These two nothing but asymptotes. Okay. Now, let us first find the equation of K, C, K3. That means, if you join any line, join K1, C, K3, that line definitely touches the hyperbola at infinity. Touches the hyperbola at infinity, that will become a tangent to that hyperbola. Sure. Okay now, right. So, what is this length? A. This length will be B. Therefore, this point will be A comma B. Therefore, the angle here theta, inclination. Therefore, tan theta is equal to B by A. Tan theta is equal, so this is 0 comma 0. This is A comma B. Slope of the line is y2 minus y1 upon x2 minus x1 B by A. Therefore, equation of the line K1 C K3 is y is equal to mx, that is y is equal to m means tan theta. Tan theta means already it's given it as B by A x. This is the equation of the asymptotes. Similarly, K2 C K4. K2 C K4. So, this line will be here tan theta will be minus B by A. So, it is in the second quadrant minus b by a. Therefore, the equation of the another asymptote is y is equal to minus b by a. So, y is equal to tan. So, the inclination is this. Here now the inclination is. So, tan theta is equal to minus b by a. Therefore, y is equal to minus b by a. So, this is actually the construction of the asymptotes. Okay, now. So, I hope that you understand these concepts and you enjoyed today's class. With some more concept and results on asymptotes, tomorrow's class I will stand before you. Until then, all the best.